concave meniscus, acute angle of contact. First we see what is the adhesive force and cohesive force. This is a glass material, so it is made up of large number of glass particles. The force of attraction between the two glass molecules is known as a cohesive force. Also, it is water. Different water molecules are present. The force between the different water molecules is also called as a cohesive force of attraction. But this water molecule is in contact with these glass molecules. So there must be some force of attraction between water molecule and a glass molecule. Whatever the force of attraction present between water molecule and glass molecule is called as adhesive force of attraction. So force of attraction between the two different materials is known as adhesive force of attraction, and force of attraction between two same material molecule is called as cohesive force of attraction. That may be the two water molecules or two glass molecules. That is a force of attraction between the two same material molecules is known as a cohesive force of attraction. We use these two forces, cohesive force and adhesive force, to explain the concave meniscus, or it is also known as acute angle of contact. So this is a glass material which is in contact with liquid. See, any molecule at the point of contact between the glass and water, this water molecule are attracted by the other water molecules inside the water. So resultant force due to all water molecules, we denote it by a C. The point of contact we denote by a P. So this PC bar gives you the cohesive force applied by the other water molecules on this water molecule at a point P. The water molecule at a point P is in contact with the glass molecules. These glass molecules apply the force of attraction on this water molecule present at a point P. The resultant adhesive force acting on this water molecule at a point P, we denote it by a vector PA bar. So PA bar is a adhesive force acting on this water molecule at a point P. So resultant, this water molecule is attracted by other water molecule, also it is attracted by the other glass molecules. So resultant of these two forces, one PC bar and PA bar, we denote it by a vector PR bar. So PR bar is a resultant of PC bar and PA bar. So this is a diagram. It is a point P where in contact with a glass. P molecule on the surface of a liquid near the wall of a container. Resultant adhesive force, that is a force applied by the glass molecules on this kerosene molecule at point P, is PA bar is greater than the resultant cohesive force PC bar. So PC bar, that is a cohesive force acting on the kerosene molecule at a point P. Therefore, net resultant of adhesive force and cohesive force is PR bar lies inside the solid. So this resultant PR bar inside the solid. For equilibrium of a liquid surface, The net resultant PR bar acting on a molecule P must be normal to the liquid surface at all points. This PR bar remain normal to the tangent at a point of contact between kerosene and glass. This surface or this molecule P move in upward direction and this tangent PT bar PT is now the perpendicular to the PR bar. So in order to remain this PR bar perpendicular to this tangent PT, this molecule P raise in some height. In order to remain PR bar normal to the free surface of a liquid near the wall, molecule P moves upward against the solid boundary. As a result of it, the liquid surface becomes concave and the angle of contact is acute. This is the case in case of kerosene in contact with the glass. Kerosene moves but point P is raised to some height and this surface becomes now the concave. So it is called as a concave meniscus. This is known as a concave meniscus. केरोसिन आणि ग्लास यांच्यामधला अँगल ऑफ कॉन्टॅक्ट हा ॲक्यूट असतो. आता हा पी मोलेक्यूल जो आहे केरोसिनचा हा ग्लासच्याही संपर्कात आहे आणि इतर केरोसिन मोलेक्यूलच्याही संपर्कात आहे. हा पी केरोसिनचा मोलेक्यूल ह्या अदरच्या केरोसिनची मोलेक्यूल त्या मोलेक्यूल पीला आपल्याकडं ओढतात आणि मग या इतर केरोसिनच्या मोलेक्यूलनी याच्यावर जो काही फोर्स लावतो तो म्हणजे कोहेसिव्ह फोर्स आणि त्याचा रिझल्टंट एकत्रित परिणाम आपण PC बारने दाखवतो. पी या ठिकाणी असणाऱ्या केरोसिनच्या मोलेक्यूलला एक ग्लासचे मोलेक्यूल आपल्या बाजूला ओढतात आणि सर्व गॅसच्या मोलेक्यूलने याच्यावर लावलेला फोर्स जो असतो तो म्हणजे ॲडॅझिव्ह फोर्स आणि या पी या ठिकाणच्या केरोसिनच्या मोलेक्यूलवर लागलेला एकूण ॲडॅझिव्ह फोर्स PA बारने दाखवला आहे. PC बार हा इकडं ओढतोय, PA बार इकडं ओढतोय आणि मग या दोघांचा एकत्रित फोर्स म्हणजे नेट फोर्स याच्यावर लागलेला तो म्हणजे PR बार इथं दाखवलेला आहे. आता हा PR बार नेहमी लिक्विड सरफेसला जो काय आपण टँजंट काढणार या पॉईंट ऑफ कॉन्टॅक्टला त्याला बरोबर परपॅन्डिक्युलर असणं आवश्यक आहे. मग आता याला परपॅन्डिक्युलर व्हायचं असेल तर हा मोलेक्यूल P जो काय तो इथं होता पहिल्यांदा तो इतका वर उचलला जातो म्हणून दाखवताना डायग्राममध्ये तो वर दाखवलेला आहे. ॲक्च्युली पहिल्यांदा इथं होतं. हा वर गेल्यावर हा टँजंट जो काय हा टँजंट आणि PR बार हे 90 डिग्रीचा कोन करतात आणि यासाठी हा मोलेक्यूल P वर उचलला गेल्यामुळं हा कर्व भाग इथं झाला आणि यालाच म्हटलं जातं कॉन्केव्ह मेनिस्कस. Convex meniscus, obtuse angle of contact. So obtuse angle of contact, we take the example of mercury and glass. Suppose the mercury molecule at a point P which is attracted by the other glass molecules. The resultant force applied by the glass molecules on mercury molecule at a point P is denoted by PA bar. Other molecules also apply the force on the mercury molecule at a point P. The net force acting on mercury molecule at a point P due to the other mercury molecules is denoted by PC bar. So PC bar attract this mercury molecule at point P towards themselves. Also the PA bar attract the mercury molecule towards it. So resultant force acting on the mercury molecule at point P is PR bar. Again, in order to remain this PR bar perpendicular to the point of contact of a glass and a mercury, The mercury molecule at point P moves in downward direction and therefore the tangent PT bar now becomes perpendicular to the PR bar. In this case, the resultant force PC bar is greater than the resultant force PA bar. Consider the molecule P on the surface of liquid near the wall of a container. The resultant adhesive force PA bar is much less than the resultant cohesive force PC bar. This word much less is now underlined, that is a reverse word than the present in the concave meniscus. इथं अंडरलाईन केलं. हे शब्द मी कॉन्केव्ह मिनिस्कसच्या स्टेटमेंटमधले बदललेले आहेत. तुम्ही पाहू शकता त्या ठिकाणी. Therefore, resultant of adhesive force and cohesive force PR bar lies inside the liquid. In previous case, PR bar lies inside the solid or inside the glass. For equilibrium of a liquid surface, the net resultant force acting on the molecule P must be normal to the liquid surface at all point. This sentence is same in both the case. In order to remain PR bar normal to the free surface of a liquid near wall, molecule P moves downward against the solid boundary. In previous case, it is moving upward. Now it is moving downward. As a result of it, the liquid surface becomes convex and angle of contact is obtuse. This is an example between the mercury in contact with a glass. So only change the words which is underlined in this topic, and that goes into the concave meniscus. Zero angle of contact. In two topics we have seen obtuse angle of contact and acute angle of contact. Now we see the zero angle of contact. For pure water in contact with clean glass, the resultant adhesive force PA bar due to the solid molecule is very strong as compared to the cohesive force PC bar due to liquid molecules. Therefore, net resultant force PR bar coincide with PA bar. This is a PR bar which is coincide with PA bar. In order to remain a PR bar perpendicular, the water molecule P does not move in upward direction or downward direction. Tangent becomes now the PT. This tangent is now makes 90 degree with resultant PR bar, and in this case angle of contact is 0. Angle of contact is 90. Condition for convexity and concavity. Here resultant cohesive force PC bar is exactly 45 degree with a solid surface and free liquid surface. This resultant PC bar, that is a cohesive force applied by the other liquid molecules, their resultant PC bar makes an angle 45 with a solid surface and makes an angle 45 with the free surface of a liquid. The net resultant PR bar is exactly vertical. This is a PR bar. Is exactly vertical. Shape of liquid drop on solid surface. Consider the liquid drop on a solid surface. Three forces act at a point P, which is at a contact between the liquid and a solid. One force pull it inside the liquid T1, other force pull it outside the liquid, that is a T2, and third force which act in upward direction, slightly upward direction, T3. What is a T1, what is a T2, what is a T3, that we see after. So angle of contact between the T3 and the surface of between the liquid and solid is theta, called as angle of contact for the given solid pair. T1, force due to the surface tension at liquid solid interface. This is liquid and solid interface, and this because of liquid surface tension, the force acting inward direction is T1. What is a T2? Force due to the surface tension at the air solid interface. या बाजूला ओढणारा फोर्स एअर मोलिक्यूल आणि सॉलिड मोलिक्यूल लावतात तो T2. T3, force due to the surface tension at air liquid interface. This is the liquid and here are the air molecules. This surface tension apply the force, that is T3. For equilibrium of a drop, equilibrium, that means if this drop is steady, then T2 is equal to T1 plus T3 into cos of theta, or we write the cos theta is equal to T2 minus T1 divided by T3. Then the molecule remain in equilibrium or steady condition. If T2 is greater than T1, T2 minus T1 is less than T3, cos theta is positive, the angle of contact theta is acute. This angle of contact is acute. If T2 is less than T1, that means T1 is greater than T2, and T1 minus T2 is less than T3, cos theta is negative, angle of contact is obtuse. This is angle of contact. In this case, your T2 is weak and T1 is greater. T2 minus T1 is equal to T3, then cos theta is 1, and in this case theta is nearly equal to 0. Not exactly, but almost equal to 0. We may show this condition on the glass surface also. So this is the condition, nearly equal to 0. That is a T3. Here is a T2, T1, and here is a T2. Fourth case, T2 minus T1 is very much greater than T3, or we say T1 is too large than T1 plus T3, cos theta is more than 1, but this is not possible, and the liquid gets spread over the solid surface and drop will not be formed. So cos theta never be greater than 1. In this, factors affecting the angle of contact. First factor, nature of liquid and solid in contact. We have seen that when kerosene in contact with a glass, then angle of contact is acute. In the same glass, if mercury is in contact, then angle of contact is obtuse. That means the nature of liquid and solid changes the angle of contact. Impurity present in the liquid also affect the angle of contact. Temperature of a liquid also affect the angle of contact. What are that effects that we see in next point? Effect of impurity, that is the second point. There are again two types of impurity. One is a soluble impurity, another is a partly soluble impurity. Impurity म्हणजे पाण्यामध्ये किंवा लिक्विडमध्ये मिसळले गेलेले इतर पदार्थ. दोन प्रकारचे इम्प्युरिटी असतात. एक पाण्यात पूर्णपणे विरघळली जाणारी इम्प्युरिटी आणि काही प्रमाणात विरघळली जाणारी इम्प्युरिटी. First we say the soluble substance. When added in a water, the surface tension of water increases. सोल्युबल म्हणजे जी इम्प्युरिटी एखाद्या लिक्विडमध्ये पूर्णपणे विरघळली जाते. इथं आपण वॉटर घेतलं. वॉटरमध्ये जर एखादी इम्प्युरिटी पूर्ण विरघळली जाणे, त्या केसमध्ये सरफेस टेन्शन हे इन्क्रीज होतं. एक्झाम्पल NaCl इन वॉटर. स्प्रिंगली सोल्युबल और पार्टली सोल्युबल मिक्स्ड विथ वॉटर, द सरफेस टेन्शन ऑफ वॉटर डिक्रीजेस. म्हणजे काही प्रमाणात विरघळली जाते, काही प्रमाणात विरघळली जात नाही. अशा प्रकारची अशुद्धी ज्याला आपण जे मिळवतो, अशुद्धी म्हणजेच इम्प्युरिटी, त्याला त्या केसमध्ये वॉटरचं सरफेस टेन्शन डिक्रीज होतं. एक्झाम्पल डिटर्जंट मिक्स विथ वॉटर और फिनॉल मिक्स विथ वॉटर, केरोसिन मिक्स्ड विथ वॉटर. थर्ड, insoluble, that is not soluble in water. If insoluble impurity is added into the water, the surface tension of water again decreases like dust in water. मातीचे कण पाण्यामध्ये विरघळले जात नाही, पाण्यामध्ये ते तरंगायला लागतात. मग त्या केसमध्ये वॉटरची म्हणजेच पाण्याचं सरफेस टेन्शन हे कमी झालेलं असतं. म्हणजे एकाच केसमध्ये ते इन्क्रीज होतं, दोन्ही केसमध्ये ते डिक्रीज आहे. कुठल्या एका केसमध्ये इफ यू ॲड अ सोल्युबल इम्प्युरिटी देन द सरफेस टेन्शन इन्क्रीजेस. इफेक्ट ऑफ टेम्परेचर. ॲज अ टेम्परेचर इन्क्रीजेस सरफेस टेन्शन ऑफ अ लिक्विड डिक्रीजेस. जसं जसं तुम्ही तापमान वाढवणार एखाद्या लिक्विडचं, तसं सरफेस टेन्शन हे कमी कमी होत जाईल. कोल्ड वॉटर हॅव अ लार्जर सरफेस टेन्शन दॅन दी hot water. So therefore, for to bath we take a hot water, not a cold water. But there is one exception. Surface tension of molten copper is increased with increase in temperature. म्हणजे लिक्विड स्वरूपातल्या कॉपरचं सरफेस टेन्शन जे आहे ते वाढत जातं जसजसं त्याचं तापमान तुम्ही वाढवाल तसं तसं. म्हणजे टेम्परेचर वाढवलं की जनरली काय होतं तर सरफेस टेन्शन डिक्रीज होतं. मग एखादं टेम्परेचर असं येतं की ज्या वेळेला त्या लिक्विडचं सरफेस टेन्शन हे 0 होतं, 0 होतं, त्या तापमानाला म्हटलं जातं क्रिटिकल टेम्परेचर. द टेम्परेचर ॲट विच सरफेस टेन्शन ऑफ अ लिक्विड बिकम्स 0 is called critical temperature. We see the few examples. When a detergent powder is mixed with water, the surface tension of water decreases and water makes good contact with the fabrics of a cloth and is able to remove the tough stains on the cloth. म्हणजे डिटर्जंट ते ज्यावेळेस पाण्यामध्ये टाकता तुम्ही त्यावेळेला पाण्याचं सरफेस टेन्शन कमी होतं आणि ते कमी झाल्यामुळे पाणी कपड्यावर व्यवस्थित पसरलं जातं आणि त्यामुळे त्यावर असणारा डाग जो असेल तो निघायला मदत होते. फॉर वॉशिंग न्यू कॉटन क्लॉथ वी यूज कोल्ड वॉटर. सरफेस टेन्शन ऑफ कोल्ड वॉटर इज लार्ज और मोर. It does not make good contact with the fabrics of a cotton cloth and therefore fabric does not lose its color. मी सर्वसाधारण घरामध्ये पाहतो, आपल्याला सांगतात जुने माणसं की नवीन आणलेला कपडा थंड पाण्यात भिजवा, काही वेळा त्याच्यामध्ये मीठ टाका आणि मग कपडा भिजवा असं सांगितलं जातं. मीठ काय आहे म्हणजेच NaCl आहे. NaCl इज कम्प्लिटली सोल्युबल इन वॉटर. पाण्यामध्ये सोल्युबल आहे आणि ते सोल्युबल असल्यामुळे पाण्याचं सरफेस टेन्शन अजून वाढतं. पाण्याचं सरफेस टेन्शन वाढवल्यामुळं त्या कपड्यावर जो काही रंग दिलेला आहे तो त्यातून निघून जात नाही, तर तो फिट्ट होण्यासाठी थोडीशी मदत होते. म्हणजे पाण्याचं सरफेस टेन्शन वाढवण्यासाठी त्याच्यामध्ये आपण NaCl म्हणजेच मीठ ॲड करतो नवीन कपडा भिजवण्यापूर्वी. Surface tension of hot water is low. Therefore, hot water is used to remove tough stain on fabrics. For to bath, we use hot water because surface tension of hot water is low